sine and cosine graphs. Now this is the standard sine graph, f of x equals sine x. Now all the points on this graph represent the solutions of sine x, where sine x has a value, but sine x is 0 at these intercepts, which corresponds directly to the unit circle. On the unit circle, sine x, which represents the y coordinate, the distance, the length of the y coordinate is 0 at 3 points, 0, pi, and 2 pi once you come around again. Now in the cosine graph, all the points again represent all the points where cosine has a value, meaning the x coordinate, the length of x has some sort of value, but at 3 pi on 2 and pi on 2, the value of cosine is 0. Now cosine is 0 at 2 points, pi on 2 and 3 pi on 2, because cosine represents the length of the x coordinate, and at these 2 points, the coordinate here would be 0 pi on 2 and 0 3 pi on 2, essentially. Sorry, no, not 3 pi on 2, negative 1 and 1. Yep. Now on to some questions. Let me just erase this. Now, when we're trying to sketch a function, we have a few components. This component here represents the dilation relative to the x-axis, and this represents the dilation relative to the y-axis. Now in this case, there's no dilation in this case. There's simply a translation of pi on 3 units to the right. Now when we're sketching a function, let's draw cosine. Okay, cosine. The easiest way to find all the points of significance, the minimum, maximum, x-intercepts, is to split everything into 4 parts. There you go, 1 part, 2 part, 3 parts, and 4 parts. Now when you split it in 4 parts, you find these intercepts, the minimum point and the final point and beginning point of this cycle of any function. Now let's get started. Now first we're going to find f of 0 and f of 2 pi. F of 0 and f of 2 pi represent the points of the first and last point of this function, because we're translating it pi on 3 units to the right. Although the period is still 2 pi, this translation means the actual function doesn't end at 2 pi, it ends beyond 2 pi, but because our domain is 2 pi, we need to find what that value is at both points. Let's get started. F of 0 equals cosine 0 minus pi on 3. This equals cosine negative pi on 3, which equals this. Okay, over here we have negative pi on 3. Negative pi on 3 is over here, and because cosine, the x-coordinate, is positive, we can just say this equals cosine pi on 3, which equals 1/2. F of 2 pi. F of 2 pi equals cosine 2 pi minus pi on 3. This is the equivalent of going 1 full revolution and subtracting pi on 3. This is our reference angle pi on 3, and because cosine is positive at this point, we're just going to write cosine pi on 3, which equals to 1/2 again. Now let's sketch this up. Let me sketch this properly. Now when we're sketching it, we're going to do the same method I just told you. We're going to split the period into 4 components. 2 pi divided by 4 equals pi on 2. So at every point we're just going to keep adding pi on 2 to find each point of significance. Now this is our starting point, pi on 3. This is our amplitude. I forgot to mention this. Pi on 1 is the dilation relative to the y-axis. So if you have a function here, oh my god. If you have a function here, the amplitude, let's say this is 1, you're stretching it relative to the y-axis up So the amplitude would, in this case, if you had 3 cosine x minus pi on 3, this would stretch 3 units up. Now let's draw some dotted lines. Okay, let's pi on 3, pi, and 2 pi, which is where we end. And because this is translated pi on 3 units to the right, the theoretical cycle should end 2 pi plus pi on 3, but because our domain is only 2 pi, I'm not going to count it. Pi on 3, okay, we start here. F of 0 is 1/2, so we'll sketch this. Pi on 3 plus pi on 2 equals 2 pi on 6 plus 3 pi on 6, which equals 5 pi on 6. This is approximately here. 5 pi on 6. Now 5 pi on 6 plus pi on 2 equals 4 pi on 3. Now 4 pi on 3 is approximately here, so we're going to sketch this down here. 4 pi on 3. 4 pi on 3 plus pi on 2 equals 8 pi on 6 plus 3 pi on 6, which equals 11 pi on 6. Now 11 pi on 6 is approximately here. Let's sketch this up. And now f of 2 pi comes useful here, because this first cycle ends around here, right? It doesn't end here, it just intersects here. Now we're just going to sketch this up here, and that's our function. That's it. Now with this function, we know that we have a dilation of 2 relative to the y-axis, and the translation of pi on 3 units to the right, and it's a sine function within the domain of 0, 2 pi. Okay, let's find f of 0 and f of 2 pi. F of 0 equals sine 2, 0 minus pi on 3. This equals sine negative 2 pi on 3. This equals, now if we look at a diagram here, negative pi on 3, pi on 3, negative 2 pi on 3, the reference angle is pi on 3 in the negative, so this is equivalent to negative sine pi on 3, which equals to negative root 3 on 2. F of 2 pi, f of 2 pi equals sine 2 pi minus pi on 3. This equals sine 6 pi on 3 minus pi on 3, which equals sine 10 pi on 3. This is equivalent to 3 pi plus pi on 3. Now if we visualize this, this equals pi, 2 pi, 3 pi, and pi on 3. The reference angle is below the x-axis, so sine equals, this is equivalent to negative sine pi on 3. This equals negative root 3 on 2. Now let's sketch this. Now we know that we have a dilation of 2 relative to the y-axis, and as per the rule 2 pi over n, which represents this dilation, our period equals 2 pi over 2, which equals pi. Sketch this out. Okay, sine 1, negative 1, that's our amplitudes. Let's draw a dotted line here. Now I suggest that you first deal with the translation and the dilation, and then also deal with the amplitude. First you deal with the amplitude, Then you want to deal with the translation. Then you want to deal with the period, which comes as a result of the dilation. Okay, our translation is pi on 3 here. And our domain is 2 pi, so should end around here. Pi on 3, 2 pi on 3, pi, 4 pi on 3, 5 pi on 3. Let's make this 2 pi. Pi on 3, okay. As I've told you earlier, the best way to go about this to find all the points of significance is to divide the period by 4. Pi on 4. So now we're just going to add pi on 4 to each of these points as we go along to find all the points of significance. Okay, because we know that f of 0 equals negative root 3 on 2, over here we can just write negative root 3 on 2 and just begin. Sine, yep. Now pi on 3 plus pi on 4 equals 7. Okay, this equals 4 pi on 12 plus 3 pi on 12, which equals 7 pi on 12. This is equivalent to approximately here, so 7 pi on 12. 7 pi on 12. Pi on 4 is equivalent to 3 pi on 12, so for ease of calculations, I'm going to continue referring to it as 3 pi on 12 plus 3 pi on 12 equals 10 pi on 12, which equals 5 pi on 6. Now 5 pi on 6 should lie approximately here. Okay, let's just adjust this. It should be maybe around here. 5 pi on 6. 5 pi on 6 plus 3 pi on 12 equals 10 pi on 12 plus 3 pi on 12, which equals 13 pi on 12. Now 13 pi on 12 lies around here. 13 pi on 12, so this should be around here. 13 pi on 12 plus 3 pi on 12 equals 16 pi on 12, which equals 4 pi on 3. Let's bring this back up here. 4 pi on 3, 4 pi on 3, plus 3 pi on 12 equals 16 pi on 12, plus 3 pi on 12, which equals 19 pi on 12. Now 19 pi on 12 lies around here. So let's just put this here, 19 pi on 12. Let's bring this up here, 19 pi on 12. 19 pi on 12 plus 3 pi on 12 equals 22 pi on 12. And this equals 11 pi on 6. Now 11 pi on 6 lies right approximately around here, which is 11 pi on 6. And then 2 pi, as of f of 2 pi, the value of 2 pi should be negative root 3 on 2. So let's bring this curve a bit down to around here. And around here, our coordinate is 2 pi, negative root 3 on 2. Let's just label all these coordinates. This is 19 pi on 12, 1. 7 pi on 12, 1. 0, negative root 3 on 2, 13. This is, yes, 13 pi on 12, negative 1. And that's our function. Next question. For the function with rule f of x equals sine 3 x plus pi and 4 within the domain, negative pi and pi. Now let's look at the information we've been given. 3 is the dilation relative to the y-axis. X plus pi and 4 is translated pi and 4 to the left because we're adding it, and go to sine function, domain is this. Alright, let's get started. Okay, find f of negative pi and pi. F of negative pi equals sine 3 negative pi plus pi on 4. This equals sine negative 3 pi on, sine 3 pi on 4. This equals sine negative 9 pi on 4. Now the exact value is equivalent to negative 8 and negative 9. The reference angle is here, where sine is negative, so the exact value is negative sine pi on 4, which equals negative root 2 on 2. F of pi equals sine 3 pi plus pi on 4, which equals sine 5 pi on 4, which equals sine 15 pi on 4. Now 15 pi on 4 is equivalent to going four rotations of pi, 4 full rotations minus pi on 4, which is 1, 2, 3, 4, minus pi on 4. You end up with an exact value over here, which is below the x-axis. This is equivalent to negative sine pi on 4, which equals negative root 2 on 2. Let's sketch this up. Okay. Amplitude is 1. Let me just write this here. 1, negative 1. Let's draw a dotted line. Negative pi on 2. Pi on 4. Negative pi on 4. Negative pi on 2. Negative 3 pi on 4. Negative pi. Okay. Negative pi on 4. Our period is 2 pi divided by n. N is this dilation here. This equals 2 pi on 3. Now we're going to divide this by 4. 2 pi over 3 divided by 4 equals 2 pi on 12, which equals pi on 6. Okay, we're starting at pi on 4, negative pi on 4, negative pi on 4 plus pi on 6 equals negative 3 pi on 12 plus 2 pi on 12, which equals negative pi on 12. Now negative pi on 12, let's say, is here. Let's place this here and here. Negative pi on 12 plus 2 pi on 12, which is pi on 6, is pi on 12. Let's place pi on 12 here. Pi on 12. Pi on 12 plus 2 pi on 12 equals pi on 4, because this is 3 pi on 12. This equals pi on 4. Let's put this here. 3 pi on 12 plus 2 pi on 12 equals 5 pi on 12. 5 pi on 12 is approximately here. 5 pi on 12. Let's put this here. 5 pi on 12 plus 2 pi on 12 is 7 pi on 12. Let's put 7 pi on 12 here. And 7 pi on 12 plus 2 pi on 12 is 9 pi on 12. This is equivalent to 3 pi on 4 right here. 9 pi on 12 plus 2 pi on 12 is 11 pi on 12. Let's dot this down here. 11 pi on 12 is around here. 11 pi on 12 Let's move this down here. And pi is negative root 2 on 2. Let's dot this down here. Negative root 2 on 2. So that should be around here. Pi negative root 2 on 2. Now let's do the other side of the axis. Negative pi on 4, which is negative 3 pi on 12, minus 2 pi on 12, equals negative 5 pi on 12. Negative 5 pi on 12 lies here, negative 5 pi on 12. So let's move this here. Negative 5 pi on 12. Negative 5 pi on 12 minus 2 pi on 12 equals negative 7 pi. Negative 7 pi on 12. Negative 7 pi on 12 is approximately here. Negative 7 pi on 12. This equals here. Okay, wait, let me just adjust this real quick. Let's say it's around here. Around. Yep, negative 7 pi on 12. Let's sketch the. Oh my god. Negative 7 pi on 12. Negative 7 pi on 12 minus 2 pi on 12 is right up here, which is negative 3 pi on 4. And negative 9 pi on 12 minus 2 pi on 12 equals negative 11 pi on 12. Negative 11 pi on 12 lies around here. Negative pi on 12. Sketch this. And our negative pi is negative root 2 on 2, which goes around here. Negative pi, negative root 2 on 2. Let's label all our maximum minimum points. This is